Good morning, students. This is Suraj Patel and welcome to Maths Chef YouTube channel. So yesterday we have discussed about the graph of the function. Okay, how the graph behaves with different angles, multiple angles and division angles with respect to all trigonometric functions. The sine have sine wave, sine function, cosine function, tangent function, cotangent function, and a second function and cosecant function. I have discussed in yesterday class. Today the next concept is sum and difference of the trigonometric function. What is that? Sum and difference of the trigonometric means how we should define. Okay, sir. Sine of two angles. Sum of two angles are sine of x minus y. Similarly, cos of x plus y. Cos of x minus y. How should we define according to the given conditions? Okay, the chance of asking questions: define the sin 30 plus 45, sin 30 plus 60, cos 30 plus 60, various angles. So this is called sum and difference of the trigonometric function. I have to define for all the 6 trigonometric functions. Okay, before going to that, start this derivation. Okay, sir. Let's see. Already you know one. Okay, sir. Sine of minus x is equal to minus sine of x for x belongs to all real number, and similarly cos of minus x is equal to positive cos x for x belongs to r. So all these are going to use in our derivations. Okay, let's divide the theorem is there. One theorem is there, have to prove it. Or the theorem is for all numbers x and y. For all numbers x and y, for all numbers x and y, prove that cos of first one is cos of x plus y is equal to the formula is cos x cos y minus sin x sin y. Cos x cos y, cos of x into cos of y minus sin of x sin of y. And then second one is cos of x minus y, the difference angle. So this becomes cos of cos y plus sin of x into sin of y. Is it? Yes. This I have to derive with respect to equation. If I derive this one, then remaining angles you can write by the following this formula. For that derivation, you need some unit circle with the difference angles. Students, listen here. For state boards and CBSE boards students, are especially the regional students, this may be quite difficult. But anyway, this is not going to ask in a state board or computer exams. But the basic knowledge, how the sum and difference angle derived with the diagrammatic manner. Okay, just consider the unit circle. Unit circle. This is the point, this is the center. Okay. This is the point A, can tell it is the B. This is the point for cos x and sin of x, because this is the angle x. This is 1 and 0 in unit circle, you know, because this is 1. The radius of the semicircle is 1. Again, let's take here. This is the angle y. This becomes q. And here q becomes minus cos x plus minus cos of x, because we are considering this angle. Okay, this is the complete circle. Okay, is it? Okay. This is okay considering this circle. Again, just considering the with respect to origin. Okay, sir. So this one, this becomes q becomes cos of x plus y and sin of x plus y. Okay. This is the symbolization. Again, here same angle. Okay, sir. This angle I am taking considering here on also. So this should be from here only, na? Okay, sir. This should be here. Okay. Again, I am considering here same also. This becomes r. Okay. This is the minus y angle minus y because it is running the anti-clockwise direction. Okay, sir. The code becomes here. Okay, sir. Cos of minus y, cos of minus y, and sin of minus y. Okay, cos of minus y and sin of minus y. So listen here. This is the minus angle. This here you can also write. This is the cos. Okay, x. This is the y from. Okay, sir. This is the minus y. Okay. If this this notations then the remaining the derivation becomes very easy. This is the angle. Okay. Again, let's see. Write the equation. Next step is draw the joint. Okay, sir. R and O. Okay, sir. Just I am not writing here. Just I am sir. Dictating. I am going to be writing. Okay, sir. Marking here. I am drawing PQ. Okay, sir. And RQA points to go before this one. Okay, sir. This is our right. Okay, sir. The arc. Okay. This is x and this is theta. Okay, sir. And this is equal. Okay, sir. R is equal to R and this is equal to R. It's similar also. Okay, sir. If this is equal to, okay, sir, is equal to y, and this becomes theta 1, this becomes r1, and this becomes r1. Okay, sir. If x is equal to y, okay, sir, then, okay, sir, f is equal to y, then r1 becomes r2. Radius also. In angle, okay, sir, in triangle, okay, sir. This is the chord, okay, sir. This is the arc length. This is x. This curve is x. Another one is there. Another circle is there. I did B. In same circle take. Okay, sir. This is the center. Again, this is the curve. This is also x. Then this becomes equal. The similar curve cuts similar chords. Okay, sir. This you should remember. Okay, sir. Similar length curve, similar curve cuts. Okay, sir. Equal or similar chords. Okay, sir. This theorem I am going to apply for this derivation. Okay, sir. Understand? Similar curves cuts similar chords. Okay, if this curve is x and this curve is x, then this curve becomes this curve. Okay, this is it right now. Here that derivation is what is our equation is PQ. Okay, sir. Arc PQ is equal to arc. Okay, sir. AR. Arc length I am taking. Okay, sir. So here I am going to add arc AP for both equations. Arc PQ plus arc AP on both sides. This becomes arc A R plus arc A AP. Yes, sir. What the arc PQ and arc AQ AP becomes? Okay, sir. PQ and AP becomes arc, okay, sir, AQ is equal to arc, okay, sir, AR and AP. This becomes arc PR. This is the, sir, I told you, the arc AQ and arc PR are similar. So this is the main crucial point in this derivation. Remaining are only stuffs. You have to notation. You have to take the notations. Okay, sir. This is even second quadrant. I am going to positive means I am taking the angle from this, from the origin. Okay, sir. This right side. So up to here only positive only. Okay. Only you are taking from this one pi by 2 plus, then becomes follow the aesthetic rule. But here you are considering the total angle, whatever it may be. So I am taking the x plus y. Okay. This arc, okay, arc AQ, this one, arc AQ and arc PQ are similar. Therefore, the chord PR and chord which one? QR are similar. Okay, therefore, chord PR, okay. Then AQ for the AQ chord is, okay, chord, okay, QA is equal to chord PR. PR. Okay, sir. So therefore QA is equal to PR. Just apply this formula. Okay, sir. This implies QA square is equal to PR square. Apply the distance formula, then you will get the result by doing some mathematical operation. The crucial point is similar curves, similar chords. Only that is the main definition. Okay, the crucial point here. Similar curves, arcs. I am telling arcs, cuts, similar chords in a circle. It may be circle, not a circle, okay? Whatever it may be. So this is the theorem, single and important theorem I am going to use for the derivation of cos x plus y. Yes, sir. Let's understand. Then let's see the QA square is equal to, okay, let's write this one. QA square is equal to PR square. PR square. Just apply the distance formula to get the desired result. Okay, distance formula is x2 minus x1 and y2 minus y1. QA square. Applying the cos of x plus y minus 1. Okay, to want more clarification, let's see whole square plus sine of x plus y minus 0 whole square is equal to, say cos of minus y is cos y, cos x minus cos y whole square plus sine of x plus sine of minus y becomes minus sine of y whole square. If this, then the remaining will be easy. Then here, just expansion to the desired result. So this is the a plus b whole square. So what I am getting here, cos of x plus y, okay, whole square, this cos square x plus, what's that? This is the sin square x plus y, that's 0. I am writing this one. Sin square x plus y. So what is remaining here? Minus 2 cos x plus y. Okay, sir, plus 1. Again, this is I have to expand plus 1. This expansion gives. Let's take this one QA square only. Okay. Then see, sir, this is the cos square x plus sin square x. Cos square x plus sin square x. So this becomes 1. This is like that. Whatever it may be. Cos square x plus sin square x is equal to 1. How I did it? So this indicates, okay, the diagram writing, okay, 2 minus 2 cos of x plus y. So this one and this one becomes 2. Okay, sir. Then see, sir, then expansion of this one gives cos, I am writing directly, cos x square sin x square is equal to 1. Cos y square sin y square is equal to 1. Okay, sir. What is left is, okay, plus 1 minus 2 cos x cos y, okay, plus, okay, plus, okay, cos x square sin x square get cancelled 1 and sin x square cos y square plus sin x square already 1. What is remaining is 2 sin x sin y. Listen. So this got 2 and this 2 get cancelled. Okay, sir. Again 2 is common here, get cancelled. Okay, sir. Here minus sign is there. I am sending the minus sign to this side. Okay, sir. This cos of x plus y be equal to, okay, sir, sending minus sign. This becomes positive cos of x into cos of y minus sin of x into sin of y. This is the required derivation. This is the required derivation. Here I have taken the direct steps somewhere else. Okay, the thing is here you should have, okay, now the distance formula I am taking. Okay, sir. This is I have applied QA square. This one QA square. If you know this one, QA is equal to R PR. Okay. The chord, both chord, okay, sir. Chord A and chord PR is equal to. How they become equal? Because curve, okay, sir. PQ, curve PQ and curve, okay, curve APQ and curve PA are similar, equal. That's why they cuts equal, similar chords. This is the important notation here. If you understood this one, then you can apply the distance formula without any, okay, sir, complexity in the derivation. Apply the distance formula, take the square, and okay, sir, just apply the distance formula, just expand it. This becomes a plus b whole square, and this becomes a square only, and this becomes cos x minus cos y. Okay, sir, p to r cos x minus cos y, because cos of minus y is equal to cos of minus y is equal to cos y. So this you can be right, cos y, sin of minus y, and this becomes minus of sin y. Okay. In this expansion, sin x is upper side, sin x, sin minus 1 is lower side. So this is gives the minus, and minus into minus becomes plus. Just only expansion only. So this is the elimination point. Cos square x plus y and sin square x plus y gives value 1 because they are trigonometric identities. So remaining is 1 plus 1, 2 minus 2 cos x plus y. Here cos x minus cos y whole square is there. A minus b whole square. Just use cos square. Again here a plus b whole square is there. A square plus a square. A square plus b square. Okay. The sin cos square plus sin square is used 1, and cos square minus sin square. Okay, plus sin square gives 1. Remaining is 2 cos x because minus is there, minus 2 cos x, and here plus is there, 2 sin x into sin y. Okay. Simple elimination only. Even though it is not would be asked in your board exams, but still the logic behind this derivation should be understood to derive the more derivative formulas, to derive the more formulas like this one. Yes, sir. This is the relation. Okay, this is if you are facing any complexities, any misunderstanding here, it's almost it is completely clarified. This is I am following the ML Agarwal book 2022 reprint. Just I am exactly following that what they given, almost compared to all given, all books. So this is the quite wonderful derivation and wonderful equation. Okay, here this book is the ICSE syllabus is gives more knowledge, more concept, more problems than the CBSE. For comparatively for JEE, you have to work hard, have to maintain the high work efficiency for reaching that one. But still, comparatively, it gives a wonderful, okay, sir, threshold. Okay, a safer zone to attain to enter the higher any competitive exams after the 10 plus 2. Okay, students, let's derive the remaining formulas by taking this as the base reference angle. Cos x plus y is equal to cos x cos y minus sin x into sin y. Okay, what we have derived is cos of x plus y is equal to cos x cos y minus sin of x sin of y. This is the base formula. Okay, sir. Then now cos of x minus y, cos of x minus y. How I am going to write this one? This I am writing cos of x plus minus y. Okay. Just follow this identity. So x I am writing cos x. Okay, cos x plus for cos y I am writing cos of minus y minus sin x I am writing sin x, and sin y I am writing minus sin y. Okay, so just expand. Cos of x is equal to cos of x into cos of minus y is cos y, the even function, cos y. Okay, sir. This sin of minus y is sin of minus y is equal to minus sin y. Okay, so minus and minus becomes plus. This becomes sin of x sin of y. Therefore, cos of minus x, cos x minus y gives cos x cos y plus sin x sin y. Next formula derivation. Okay, then again for next one, cos of pi by 2 plus x. Cos of pi by 2 plus x. Okay, so this is the formula continuously we are using cos of plus x. This gives cos of pi by 2 cos of x minus sin of pi by 2 sin pi by 2 into sin of x inside cos 0. Okay, sir. Cos of pi by 2 gives 0. Our condition, okay, our trigonometric quantities. So this gives 0 value. So this gives cos pi by 2 is minus 1 plus 1. Sin pi by 2 is equal to 1. Therefore, this gives minus sin of x. Therefore, cos of pi by 2 plus x is equal to minus sin of x. First entities. Okay. In diagram, please sir. In a diagram, how we define this one? Okay. Only one thing I will show you. This is the inner circle. Okay. This is the inner circle. Okay. This is the 1 and 0. Okay. This is the cos x. Functioning arithmetic A and B, point B. Okay. This is the x. Okay. This would be the minus x. Okay, sir. And this I am writing cos of pi by 2. I am writing this one. Cos of pi by 2 plus x. I am writing cos of pi by 2 minus x. Cos of pi by 2. Sir. This is minus x and this becomes, okay sir, this side becomes, let me appear carefully. So this angle becomes pi by 2 minus x. This angle. Then this becomes gives cos of this angle, cos angle. Okay, this is the adjacent. This is the opposite. Okay, cos of pi by 2 minus x gives. What is the adjacent is? This is minus b na, minus b into 1 minus b by 1. Our trigonometric condition. This is the adjacent to this angle. Therefore, this gives minus sin x. So this gives cos of pi by 2 plus x. This understanding. This gives pi by 2 minus x. Okay. The whole is pi by 2. This gives pi by 2 minus x. Okay. This gives, then this is the angle. Okay, sir. This is the plus b. This is the plus a. What do you want? Cos pi by 2 minus x gives b by 1. B by 1 gives sin of x. Okay, sir. Simple only. For sin also, sin pi by 2 minus x. This gives opposite side. Okay, the positive. It gives a. Again, derived from the formula. They are given like that only. This is the dichromatic only for the understanding. From here also you can derive the equations that pi by 2 plus pi by 2 minus pi something else, whatever it may be. From that formula also you can use. Yeah. Cos of pi by 2 plus x defined. Then cos of, okay sir, cos of pi by 2 minus x. Okay, so the minus you have the value cos pi by 2 into cos x plus sin pi by 2 sin x. So this gives 0 into cos x plus this gives 1, so this gives sin of x, so this gives sin of x cos of pi by 2 minus x is sin x. Okay. Next, the subsequent concept here, sin of pi by 2 plus x. Okay. Sin of pi by 2 plus x. So here we can use for sin of pi by 2 plus x. Okay. Let's take the first one, cos of pi by 2, sin of pi by 2 minus x. They have to divide based on this. Okay. So this gives, what is sin x here? I am writing cos of pi by 2 minus of pi by 2 minus x, because cos of pi by 2 minus x is equal to sin x. So this is the value. Okay, sir. And this gives, okay, sir, cos of pi by 2 plus minus pi by 2 plus x. Pi by 2 by 2 can cancel, gives cos of x. Therefore, sin of pi by 2 minus x gives cos x. Similarly, sin of pi by 2 plus x, this we can write sin of pi by 2 minus of minus x. What is sin of pi by 2 x? This gives cos. Okay, sir. Pi by 2 minus x gives cos of minus x. This gives cos x. Is it? Answer. Sin of pi by 2, sin of pi by 2 minus x and sin of pi by 2 plus x gives the cos x. If you want more clarification, let's see in the diagram how they will represent it. Let's see how the cos pi by 2 x and cos pi by 2 minus x, they have the, okay, sir, both equal angles. Okay, this is the unit circle and this is the point cos x. Okay, A and B point. This is x. This is pi by 2 minus x. Okay, sir. This is the opposite. This is the adjacent. This is the B. This is the A. Okay, sir. What is sin? Okay, sir. Sin of pi by 2 minus x. This angle. What is opposite by hypotenuse? What is opposite? A by 1. This gives cos of x. Okay, sir. Similarly, this I am taking, okay, sir, this minus x, and this becomes pi by 2 minus of minus x. So again, minus of minus x. Again, okay, sir, this is the A, this is the minus B. What do you want? You want sin of, okay, sir, pi by 2 plus x. I am writing this as sin of pi by 2 minus of minus cos x minus x. So this gives here, what is sin opposite by hypotenuse? Opposite is A by 1. So this gives cos of x. Similarly, you can tell sin of pi by 2 is equal to sin of pi by 2 plus x. Also you can define, both gives same value, cos x and cos x. Next, formulas. In this class we will revise the almost all formulas. Let's try So next class we will solve the problems based on these trigonometrical different sum and different formulas. Next formula is, we can call it a formula Siddhan, sin of x plus y. This you can write sin of x plus y, you can write, okay sir, for the entity. This you can write cos of pi by 2 minus x plus y. Only the difference is okay, sin of x plus pi by 2 is equal to sin of x minus pi by 2. Pi by 2 minus x, pi by 2 plus x gives cos x, and cos of pi by 2 minus x gives sin x, and cos of pi by 2 plus x gives minus sin x. This is the difference, is it? Cos of plus gives minus, cos of minus x, cos of pi by 2 minus x gives sin x, and cos of pi by 2 plus x gives only minus sin x. Okay. This is easy to remember, you can do it. But here cos pi by 2 minus is positive, positive is negative. Okay, just expand it. Okay. Just cos of pi by 2 writing sin of x plus pi by 2 writing as cos of pi by 2 minus x plus y. Okay. To make the simplification, just I am changing the signs. Pi by 2 minus x minus of this gives the minus of y. Okay, cos pi by 2 minus x and minus y. Just expand it. Cos x, cos formula, cos pi by 2 minus x cos y. So the minus is there, so you have to write plus sin of pi by 2 plus minus x either sin of y. So this gives, what is cos of pi by 2 minus x gives sin x into remaining is cos y plus sin pi by 2 minus x is cos x into sin y. Therefore, sin of x plus y gives the ratio. The formula for this one is sin x plus cos y. Let's check the cross check. Sin x cos y and cos x sin y. Okay, sir. Sin of x plus y. Only derivation is I am writing this is the in terms of cos pi by 2 minus x plus y, and just the rearrange term pi by 2 minus x and minus y. Expand the cos x plus y in terms of cos x plus y. So this gives, this is the cos x cos y, sin x and sin y. Okay, minus x. So cos pi by 2 minus x is equal to sin, and sin pi by 2 minus x is equal to cos x. Okay. Next one is similarly on the base of this one. Okay, sin of x plus y. Sin of x plus y, how I am going to write this one is sin of x minus of minus y. You can write, just expand. Okay, we need x minus y. x minus y. This we can write sine of x plus minus of y. So expand by the sine function. So for sine of x I will get sine x. For cos of I will get cos of minus y. For plus is plus. For the cos I am writing x, and for sine I am writing minus y. So this gives sine x. Cos of minus y is cos y. So this gives sine of x cos of y. Okay, sir. Sine of minus y is minus sine. Therefore, minus cos x into sine y. Is it? Sine of x minus y gives. Is it? Sine of x, sine x minus y, cos y minus cos x, sine y. Okay. Still have the numerous derivations. Let's do. Okay. Next derivation is next one is tan. Okay, in terms of tangent, tan of x plus y. I am writing this is sine of x plus y divided by cos of x plus y. So here x y does not belongs to 2n plus 1 pi by 2, and n belongs to integer. So there should not be odd multiples of pi by 2. X plus y should not be a odd multiples of x plus y pi by 2, because cos pi by 2 is 0. Because cos pi by 2 gives 0. So 1 by 0 gives indefinite, not a definition. Okay. Okay, will be next, just expand it. Okay, sir. Sin x plus sin y. This gives sin x, okay, cos y plus, okay, cos x sin y whole divided by cos x cos y. So plus either minus sin x sin y. Okay, sir. To make the angle perfection, here I will divide. Okay, sir. Divide the numerator and denominator with by cos x cos y. Cos x into cos y. Then this gives cos x into cos y. Then this gives sin x cos y divided by cos x cos y plus cos x. Okay, here is not possible to write over there. Okay, this gives tan of x plus y gives sin x cos y divided by cos x into cos y plus cos x into cos y divided by cos x into cos y. Something is gonna. This is sin x. Okay, this is the cos x. This is the cos x into sin y. Okay, whole divided by cos x cos y divided by cos x cos y minus sin x sin y divided by cos x cos y. Okay, then directly we can write cos x, okay, sin x, sin y, cos y get cancelled. Sin x by cos x gives tan x. Okay, sir. Tan of x, okay, plus cos x get cancelled. This gives tan. Sin y by cos y gives tan. Okay, sir. This cos x, cos y get cancelled. 1 remaining. Okay, sir. Sin by x, tan x, sin by y, cos y. This gives tan x, tan y. Therefore, tangent of x plus y gives tan x plus tan y and minus tan x tan y. Okay, sir. Similarly, I'm not going right here. Tan of x minus y, this gives tan of x minus tan of y divided by 1 plus, okay, tan of x tan of y. This is also true for, okay, sir. Here x minus y should not belongs to 2n plus 1 pi by 2 and n belongs to any integer value. Tan of x minus y. What tan x minus tan y? Okay, sir. Yes, sir. Similarly, almost all angles are same here only. Okay. So let's next we will write the equation almost all. Okay. Derivation is enough for up to here. We need derivation. Remaining all simple things only. So derivation means only cos x plus y, cos x minus y, sin x plus y, sin of x minus y. That is only. Remaining have to remember what is the values on the. So let's see the next equations. Next is I am not going to derive the equation. It takes the lengthy time. Okay. What I am just I am writing the formula. So derivation is very easy. Just put this some variations. Okay, sir. The cot of x plus y is equal to cot x cot y minus 1 and cot y divided by cot y plus cot x. Okay, sir. Here over there you are dividing the cos x by cos y. Here I have divided sin x by sin y. This gives. So for positive you will get the negative numerator and positive denominator. Cot x of minus y is equal to cot x cot y plus 1 divided by cot y minus cot x. Tan of three angles. Tan of x plus y plus z is equal to tan x tan y tan z minus tan x tan y tan z. 1 minus tan x and tan y minus tan y into tan z minus tan z into tan x. A sin of x into sin of x minus y. Okay, sir. This is very important. Sin of x plus y into sin of x minus y gives sin square x minus sin square y. Similarly, cos of x plus y into cos of x minus y gives cos square x minus sin square. Okay. Cos of pi minus x sin is equal to minus x and cos pi plus pi is equal to minus. This is the important. Okay. This gives for both. And cos of pi minus x and cos of pi plus x gives minus cos because in third quadrant. Okay, sir. This is in the second quadrant. Cos is negative. In third quadrant also cos is negative. Okay, sir. This is pi minus x. Okay, second quadrant cos is sin is positive. In third quadrant sin is negative. Okay, sir. This is like that cos minus x. This is cos 2 pi x minus means 0 degree. Okay, sir. This gives minus cos 2 pi minus x is equal to minus sin 2 pi x. 2 pi minus x is equal to minus sin x. Cos 2 pi minus x is equal to cos x. Okay, sir. Next we will see the next some formulas again. Yes, sir. Next is tan. Okay, sir. Tan and cotangent, sec and cosecant. Listen here. Okay, sir. In all multiples. Okay, sir. Here is just a single sin theta. Yes, sir. Sin tan, and sec are called functions. Okay, sir. If they are called functions, okay, sir, then cos, cot, and cosec are called co-functions. Co-functions. Okay, sir. If means co-function means at the pi by 2. Okay, sir. At odd multiples of pi by 2. Okay. This is the 2n plus 1 pi by 2. N belongs to z. Any integer. Changes the sign function to co-function. Here, if pi by 2 applied, n is pi by 2 multiples of pi by 2. This changes the sign. Okay, so that sign the function. Sine becomes co-function, tan becomes cotangent, and sec becomes cosec. Sine becomes cosine, tan becomes which one? Cotangent, and sec becomes this one, cosec. Okay, sir. Here you should apply the ASC rule. Where are you getting? This is the first quadrant. This is the 0 to less than equal to pi by 2. Okay. This is 0 is less than or equal to x less than or equal to pi by 2. Okay. This is the second quadrant. Here is okay. Pi by 2 is less than or equal to pi. Okay. This is the third quadrant. Okay, sir. Here pi is less than or equal to okay, sir, less than x equal to less than 3 pi by 2. Okay, this is the fourth quadrant. This is 3 pi by 2 is less than or x is equal to less than or equal to 2 pi. Okay, then apply the ASTC. All positive, sine positive, tan positive, cos is positive. ASTC rule. ASTC rule. Okay, sir. By that only you can define. Okay, sir. Remember the odd multiples, it changes. Okay, sir. Co-function changes. Odd multiples. Odd multiples of pi by 2. Odd multiples of okay pi by 2. Odd multiples of angle pi by 2. This is remaining sin pi and okay, sir. 180 degree pi and 2 pi give the same function with respect to conditions applied to the sine. Okay. One more important thing is that the maximum and minimum value of the a cos x plus b sin x is there. We will derive the condition, that one. Yes, sir. A simple, small concept. Okay, sir. The maximum and minimum value. Okay. Value of a cos x plus b sin x. Then function is there. Okay, sir. Just here I'm taking considering put a is equal to r cos alpha and b is equal to r sin alpha. So this becomes okay, so a square plus b square is equal to r square. Okay, r square into cos square alpha plus sin square alpha. This becomes 1. Therefore r becomes okay, so square root of a square plus b square. Okay, by definition you have okay, sir, f of x is equal to putting a cos okay, sir, r cos alpha cos x plus r sin alpha sin x. And this gives r to be common. Cos x plus sin x. Okay, so this is cos x plus sin x is equal to cos of x plus alpha, x minus alpha Okay, cos of x minus alpha gives, okay, okay, sir. This already you know. Okay, sir. What is cos x? So minus 1 is less than equal to cos x and less than equal to 1. Similarly, minus 1 is less than equal to cos of x minus alpha less than equal to 1. Multiplying the r on both sides, minus r less than equal to cos of x minus alpha less than equal to r. So therefore, what is the minus value? Okay, there. This is the plus or minus, na? The root wire. So this becomes minus r becomes minus square root of a square plus b square less than or equal to cos alpha x minus alpha, and this gives positive a square plus b square. What are we doing? Okay, sir. This is the minimum value. This is the maximum value for the corresponding. Correspondingly for equation ax plus cos ax plus a cos x plus b sin x. Okay, sir. This is the, okay, sir. Just only take the minimum or plus. Okay, so maximum becomes a square plus b square. Plus is maximum, minus is minimum. For any formulation, you can solve by using that formula. Root of, okay, sir, root of a square plus b square. They give a and b are the arbitrary constants. Okay, sir, coefficients of that cos x and sin x respectively. Okay, students, this is the conclusion. I am going to conclude this class for the year. Next class we will solve the variety of the questions based on these. Okay, sir, almost these given formulas, and just recall this one if possible. Try to memorize it. Okay, whatever it may be. These are very important to solve the our next year questions and ready for the competitive exams also. Various competitive exam for the academic courses or competitive exam for the all job entrance exams of the jobs. Okay, thank you for watching. Please, any mistakes or any updates, please give the right feedback on the comment box to update myself, to correct myself. Okay, thank you very much.